This is the pre-assessment for monomials. The first question that we have is we have an expression and we have values that we have to substitute in. So wherever we see an n, we're going to substitute a -6. Wherever we see an m, we are going to substitute a -4. So notice that double negative is going to be very interesting. So we're going to write n, which is -6 minus, and then the m value, which is -4, and we're going to square that. So now we have to think about what orders of operations. So we have to do exponents. What's the base of that exponent? The base of this exponent is just the -4. So we're going to square -4. We can't combine those double negatives yet because that's multiplication, and multiplication comes after exponents. So we have -6 minus, and then whatever -4 to the second power is. -4 times -4 is +16. But notice it ends up negative because of that negative. We're bringing it down. And we have -6 minus 16, which gives us -22. On the next one, we're going to substitute those values in for the variable. Whatever x is, which is 2, we're going to replace it. And wherever we see a y, we're going to replace it with a 3. So 2 plus 3 squared. Notice we don't have parentheses here because we didn't have that negative that we had to include with the base. So we're still going to do orders of operations. We're going to do exponents before addition. So this becomes 3 plus 9, and 2 plus 9, and that gives you 11. Said that so confidently too. Here our b value, we're going to substitute in for a 2, and our a value, we're also going to substitute a 2 in for it. So we get 2 plus 2 squared, that's 2 plus 4, which gives me 6. Last one, wherever we see an x, we're going to substitute a -5. Wherever we see a y, we're going to substitute a 2. Notice the operations, the 2 and the negative, are not changed. I'm just going to substitute whatever x is, -5, and then I replace the square and the minus, and then whatever the y value is, I'm just going to write in. So that is -5 squared, which is 25 minus 2 is 23. Simplify each sum, so we are adding like terms. Like terms have to have the same variable to the same exponent. So we have to make sure that that is p to the second, and that p to the third is going to be different. Those are like terms. And whenever we have like terms, we're going to combine their coefficients. So p, 4p squared and -3p squared. And then we're going to combine the coefficients of -2p to the third and -4p to the third. So let's combine those. 4 and -3 makes 1p squared. -2 and -4 makes -6p to the third. We always want to remember to put it in standard form. So standard form would tell me to write -6p to the third first, and then p squared second. And notice I did not include the 1 as the coefficient. So let's do like terms. We have 7n squared and 4n squared. We have 7n and -4n. So I'm going to write the n squares before. Coefficients are 7 and 4, which makes 11n squared. Coefficients of n's are 7 and -4, which makes +3n. We're looking for like terms. I see v squared and v squared. I see a constant and a constant. Variables are always going to come before constants. So my coefficient of v squares are 8 and 3. That makes 11v squared. And then my constants are -8 and -7, which makes -15. Like terms, -7x to the third and positive 5x to the third. Don't forget that negative in front of the 7. I have -x and -3x. -7 and positive 5 makes -2x to the third. -x and -3x makes -4x. All right, we can't combine these like terms even though r squared and r squared. First, we have to distribute this positive. We have to do that first before we can add those like terms. Okay, because the parentheses are there and they are separating it and we're not able to do that. So the positive in front of the parentheses does not affect the parentheses to the left. So those terms do not change. Or they are going to stay as -2r plus 6r. Then we're going to take a positive 1 times a -6r, which keeps it as -6r, and positive 1 times -2r squared, which keeps it as -2r squared. Now we're going to look for like terms. There are no parentheses. They've been removed because we've distributed. And let's combine those like terms. You have a positive 6r squared and a -2r squared. That gives us positive 4r squared. We have a -2r and a -6r, which makes -8r. We do the same thing. We have to first distribute that positive. We get 3b plus 6b squared minus 6b cubed minus 4b. Ooh, I like this. So we have 3b and -4b are like terms. Positive 6b squared does not have a partner, and nor does -6b cubed. So we want to write it in standard form. So we'd write -6b cubed plus 6b squared minus b, because our coefficients are 3 and -4, which makes -1. So notice my answer is in standard form. Standard form is alphabetical order, and then when they have the same variable, like in this case, each of them has the variable b, we put it in descending order by its exponent. B to the third, b to the second, b to the first. So this would be the only answer we would accept. This one, now we have to distribute a negative, and that will make a difference. Difference, get it? Subtraction. So it still doesn't affect the parentheses in front of it, but -1 times 3r cubed is -3r cubed, and -1 times r squared is -r squared. Now we again go back to combining like terms. Like terms have the same variable to the same exponent. So 2r cubed minus 3r cubed gives us -r cubed. -r squared and -r squared is -2r squared. Remember, do not write a -1 as that coefficient of r cubed. We're going to distribute. We have -6x squared minus 2. -1 times 7 is -7. -1 times -x squared is positive x squared. So we want to combine like terms. We have x squares and x squares. We have constants and constants. So -6x squared plus x squared. -6 positive 1 gives me -5x squared. -2 and -7 gives us -9. Simplify each sum. Now we have multiple variables. So when we're looking for like terms, this one's relatively easy, u cubed. And now we got to make sure that these variables are the same. This is u cubed v cubed, and this is u cubed v cubed. Both variables have to be the same, and both variables have to be to the same powers. So u cubed, oh, look at this one. What's going to come first? So when it's tied, and this one is u cubed, and this one is u cubed, well, let's simplify it first. I'm getting ahead of myself. Sorry about that. Let's simplify. So you have -8u cubed and -7, which makes -15u cubed. And then we have -2u cubed v cubed and +8u cubed v cubed, which makes +6u cubed v cubed. And now, in standard form, which one's going to come first? Well, they both have u cubed. This one doesn't have a trailing variable. This one does. So that's going to come first. You're always going to do the one with technically the most variables, I guess. If it's a tie, if you need to go to a tiebreaker and one has a variable and one doesn't, then you would write the one with more variables. That's an interesting one. I'm glad we did that one. And let's check this one out. Let's find if does it have a partner? Yes. And then we see that this doesn't have a partner and this doesn't have a partner. So let's simplify that. -4u cubed and -8 is -12u cubed. We have +5u squared v and then +4v cubed. So let's look at the first variable in each of these. You have a u, and a v. So STUV, u comes before v, so these two terms are going to come before this. So we know that this is going to be third in line. Now we have to check and see between these two. So let's group that back. So we've got this u to the third and u to the second. Well, u to the third's always going to come first before u squared. So technically, this answer is in standard form. So this is the answer that we would get. That's a good one too. Good practice. All right, we are going to distribute this positive. That gives us 5x squared y minus 4xy. Positive 1 times xy is positive xy. Positive 1 times positive 2x squared y is positive 2x squared y. Let's look for like terms. 5x squared y, 2x squared y, -4xy, and positive xy. We're going to combine their coefficients. 5 and 2 makes 7x squared y. -4 and positive 1 makes -3xy. Are we in standard form? We have x squared and x. We always start by looking at the first variable. Don't worry about the second variable. We only go to the second if they're tied in the first. But this is x to the second, and this is x to the first, so we know that x to the second is going to come first. So this is in standard form. Here on number 16, we have to distribute that negative. Left side stays the same. -1 times 7x is -7x. -1 times 6y is -6y. Let's find like terms. You've got -6x and -7x. You've got -8y and -6y. Combine their coefficients in the x's. -6 and -7 makes -13x. -8 and -6 makes -14y. Standard form is alphabetical. X's will always come before Y's. Now we are multiplying monomials. Before we were just combining. We were adding and subtracting, and we can only add and subtract like terms. We can multiply unlike terms. We just have a trick when we have like bases. So the first thing you're going to do is you're going to look at those coefficients, -5 and +5. You're going to multiply those. That gives you -25. Now we look for like bases. They both have k's. When we have like bases and we are multiplying, we add their exponents. So you're going to have negative 2 plus negative 2, which gives us negative, oops, sorry, forgot the k, that would be important, negative 25k to the negative 4. Notice they only want you to have positive exponents. So we have to deal with this negative exponent. The base of that negative exponent is k. The 25 is not affected by it. So my answer becomes negative 25 over k to the 4th. Number 18, we multiply their coefficients first, negative 8, negative 1. Negative 8 times negative 1 gives me positive 8. We have like bases, so we are going to, and we are multiplying, so we will add those exponents. So that becomes negative 2, I keep doing that, I keep forgetting to write the variable first, v to the negative 2 plus negative 4. And that becomes 8v to the negative 6. We have to deal with the negative exponent. This base has to move. It's in the numerator, so 8 stays in the numerator, and my v goes down into the denominator. And the sign of that exponent changes to a positive. Coefficients first, negative 4 times negative 2 is positive 8. We have like bases. We have a to the first and a to the 4th. So that's a to the 1 plus 4. And then we have a leftover b in there. That is b to the 2nd. We're going to simplify. 8a to the 5th, b to the 2nd. We have positive exponents, so we don't have to do anything. Negative 4 times negative 1 gives me positive 4. We have x to the 1st, x to the 4th, x to the 1st plus 4, and then we have y to the 3rd and y to the negative 2. Because we are multiplying those monomials, we know that we will add the exponents of like bases. 4x to the 5th, y. Notice I didn't write y to the 1, even though it's y to the 1. The answer is not going to include that 1. Now we have division. We look at their coefficients again. We have 2 and negative 3. That fraction cannot be reduced. So I don't need to do anything. I just keep it as 2 in the numerator, negative 3 in the denominator. But I do have like bases. And when I have like bases and I'm dividing, I'm going to subtract those exponents. So I'm going to subtract the numerator. So that is n to the numerator minus the denominator, which gives me 2n to the negative 4 over negative 3. I have to get rid of that exponent, that negative exponent. I can't leave it as negative because the directions say only positive. So I'm going to move the base of that exponent. So it becomes 2 over negative 3 n to the 4th. So we notice that the term n to the negative 4, n goes to the denominator, and my exponent becomes positive. Let's look at this one. We deal with the coefficients again. 2 and negative 4. So if I saw that fraction, how would that reduce? That would reduce to 1 over negative 2. And then we have like bases. So we have to deal with those exponents. That becomes x to the negative 1 minus negative 4. I'm going to drop off this coefficient of 1, and I'm just going to write x to the negative 1 plus 4 over negative 2. I'm going to simplify that, x to the 3rd over negative 2. That would be my final answer. I don't have to move that base of that exponent because the exponent is positive. Coefficients, there are no, well, coefficients not going to simplify. This becomes x to the 4 minus 4, y to the negative 4 minus 2. 2x to the 8th y to the negative 6. We remember 2 negatives become positive, and then we have to move that negative exponent. So 2x to the 8th stays in the numerator, y goes to the denominator, and the exponent becomes positive. We again don't have any coefficients that need to be simplified. That's 2x to the 2nd minus negative 4, y to the 0 minus 3. That's 2x to the 6th, y to the negative 3, which my final answer ends up being 2x to the 6th over y to the 3rd. Now we have power of powers. This is the only time that we can distribute across multiplication. We're going to distribute that exponent to each of the things inside the parentheses. That's negative 5. We're going to put that in parentheses because we want to attach that. That's 1 times 4 and n to the 4 times 4. So that becomes negative 5 to the 4th, n to the 16th, and negative 5 to the 4th. Let's do 5 negative to the 4th power gives me 625. 625 n to the 16th. Because that's negative 5 times negative 5 times negative 5 times negative 5, which is 25 times 25. Number 26 becomes 7 to the 1 times 3, v to the 3 times 3. 7 to the 3rd, v to the 9th. 7 to the 3rd power equals 343. These are big numbers. We again have a negative coefficient. To the 1st times 3, v to the 2nd times 3. That's negative 6 to the 3rd, v to the 6th. Negative 6 negative to the 3rd gives me 216. Notice it is negative 216. We have negative 6 times negative 6 times negative 6. We have 3 negatives multiplying each other. When we have an odd number of negatives multiplying, we will always end up with a negative answer. So negative 216 v to the 6th, 3 to the 1 times 4, n to the 1 times 4, 3 to the 4th, n to the 4th, 3 to the 4th. At this point, hopefully people are seeing, remembering, retaining that information, equals 81. All right? I think that's pretty good. Come and see me if you have questions.